This tech demo is about Stoplight, which is a tool that lets you design and test APIs. And we had an opportunity to work with this tool in our tech research team. We also published an article already, but we thought that the need to create APIs is kind of universal, so it might be a good idea to also show you a bit more in the form of a demo. But maybe before we get to Stoplight, we should start with the basics. So what is an API? There are, of course, many like formal definitions, but let's have a more practical view. API, of course, stands for Application Programming Interface. And basically what it does is that it helps us communicate with various services in a programmatic way. So instead of accessing, I don't know, Reddit, Twitter, many other services, as a user through a web interface, we can access these services through a program, through our code. Usually, API allows us to communicate in a format that's very easy to process by a computer. So as we will see later, that's JSON, for example. So we can both send requests to some other service in a JSON format, and we receive the answer in a JSON format. Or we can use XML or anything else, any other format that we can process easily in code. This is, or what's an API good for? Well, it allows us to create very interesting app integrations or automate tasks, create more complex ecosystems of various services, which in the end creates a lot of value. But as I just learned yesterday, there are also certain risks to APIs. For example, during in my PhD research, I am using the Twitter API, and there will be a lot of changes in their API. The API was free for now, at least for academic research. But yesterday, there was a tweet that they are changing their conditions, and basically the API will be paid. So that will be interesting. They basically gave developers like a week to adjust, so that will be a lot of fun. But what if we wanted to create our own API? How would that look like? We have multiple options, and in this presentation, I'm going to talk about probably still the most used, although one could argue that GraphQL is getting more and more popular. But the way to implement an API, very common way, is to use the HTTP protocol, which is also used for web and websites. And in this protocol, we have different operations. When we are loading a page from a website, it is usually a GET operation. And we can use this operation to implement an API endpoint that will allow us to receive some data from the server. Then there are other operations. You probably know POST, which is used commonly in the web when we are, let's say, submitting a form and we need to send some data to the server to process. But in terms of an API, we can use the POST method to modify some existing object in our database. Then we can use methods such as put to create a new object and delete to remove an object. So everything revolves around different HTTP methods we can use. And then we can have different URLs that, let's say, represent different objects, different sub-services in our APIs.
Sorry, may I? I think you have a mistake because POST is for creating new object and put is for modifying.
Yeah, I think you're right. I was thinking about it. Yeah, you're right. Yeah, there is a mistake there. So yeah, post is for creating, put is for updating an existing object. And as I mentioned, one of the most common formats of exchange is JSON, but nothing prevents you from using, let's say, XML or something else. And then we can also kind of extend these requests with extend the functionality of our API with HTTP status codes, which can then tell us if the response from the server was a success, a correct response, or if there was some kind of an error. So typically, probably everyone knows the 404 error, which indicates that the resource that we are looking for was not found. And we can utilize the status codes in an API to report various problems. And at the same time, we can also use request headers, also provided by HTTP, to, let's say, authenticate the API user, the client. Sometimes this form of an API is called a REST API, but from what I researched, it's not entirely correct, or it's not enough to call an API a REST API if it does what we described here. There are some other things that your API has to fulfill to be correctly to be a correct REST API. These things include things such as cacheability. So in other words, your API or the responses of your API should be cacheable. They should also be, or your API should also be stateless. So you shouldn't store any information about the client that's making the request in between different requests. And there are many other rules that should be fulfilled if the API should be truly called a REST API. Now, to define an API, one of the options that we have is using something called Open API. An Open API is basically a format that lets you specify or basically create an API schema as an YAML or even a JSON file. And so maybe just to give you a short preview how this looks like, let me just really quickly one of my projects here. Yeah, this is an example. It's a bit small, the font. But this is an example of an Open API file that defines the sort of an API that we just described, that uses HTTP, various HTTP operations, and so on. So, for example, here we have a list of paths or URLs that the users can access in our API. And for example, this one is called industries, and it defines a get operation. We can provide here a summary that says that this gives us a list of all the industries, and even an example of how an output should look like. And then we define the schema of the answer, or the response. Here we say that the endpoint, the get operation, in case it returns a 200 HTTP code, so a correct response, then it returns an array of components. We'll get to that shortly. Of a component called industry. Components basically allow us to reuse schemas. If we have let's say, multiple endpoints that define or return objects that look the same, we can define a component, let's say it's industry component, and reuse it over different endpoints. If we get down to the component, there it is, the component called industry, and it defines, most importantly, the properties that this object has. So each industry here has an ID, it has a name, and it has a count. And for each property, we define a type. So we can say that the ID is an integer. However, as you might see, it is probably not the most pleasant way to work with this file directly. And that's, let me switch back to the slides. That's where Stoplight comes in. Stoplight, at its core, is a graphical editor that allows you to edit and create these YAML files. That's at its core, but then they put a lot of additional functionality on top of this basic idea. So besides editing this OpenAPI file, they also give you a mock server that can give you mock responses from your API. This, for example, lets your the team that works on the client part that consumes the API work kind of independently from the team that implements the API. They also support Git integration and automatic documentation generation and sharing. So they have a lot of additional features besides editing open API files. So let's finally get to the more interesting part, the demo. And what we are going to implement is basically a very simple student management API that will have three endpoints. First, there will be a get endpoint at /students that will give us a list of all students. Then we will have get students /ID to get information about one specific student. And finally, there will be a post endpoint that will allow us to create a new student. And this post endpoint will be additionally protected by an API key. By the way, maybe just one thing that I didn't do correctly here, at least I read that it's a best practice. Probably the get endpoint should be in singular, should be student/ID. That's or at least some people think that that's the best practice when developing an API. When getting one object, it should be in singular. In this case, I will just stick with plural. And we will also do a very basic implementation of the API using connection, which is a very simple Python library based on Flask that lets us basically take the OpenAPI specification and implement the API super quickly. Okay, so I guess let's get to it and see if the demo gods will be good to us today. And yeah. So let's start here. This is the basic interface of Stoplight. Stoplight is accessible both as basically a software as a service in the web, but you can also download an offline editor. But for some reason, recently they added a requirement to also have an account, if an online account, if you want to use the offline editor for some reason. But basically, the main difference is that the offline version is only for editing. It doesn't provide additional features such as the mock server. That's only available in the online version. So that's what we are going to use today. And we start by creating a new project here. So plus here. And what's nice about Stoplight, it can basically connect to an existing Git repository and kind of synchronize your code, the implementation of the API with its definition. So that's a very nice feature, and we are going to use it. So I'm going to add a new GitLab project, which I have prepared beforehand. Okay, and so here, yeah. This is just an empty Git repository. There is nothing in there. We click Add Git project, and now we can go to the editor. So we click Edit. As you can see, it's cloning the repository, and now we are inside the editor. Now let's create a new API. So we just click the API button here and give it a name. So let's say students. I will also switch the OpenAPI specification version to 3.0 because for some reason the connection library actually doesn't support the version 3.1. That's something that we learned during researching this product. And we create the API. And what you can see here is basically the table of contents of what's currently present in our YAML file that's hidden behind this editor that we are actually modifying. We have a form here where we can basically edit anything in the API. But if we want, we can go to code directly and directly edit the code of the OpenAPI specification. But let's get back to the form. And the first thing that we are going to do is we are going to create a new model. Model is basically the components that I showed you earlier. So I showed you an industry, and in this case, we are going to work with students. We'll create a new student model. So just right-click model, and let's name it student. And now we can very simply edit the schema. So we have an ID here. I will switch that from a string to an integer. And as you can see, we can set various properties here. We can, for example, set that the student ID always has to be greater or equal to 1. Next, what I will also do is I will set this field as nullable, because in some cases we will use the student object without the ID. Okay, so we say that this field can basically be null. And we have defined an ID, and we can add a few more properties here. So probably each student will have name, which will be a string. And what we can also add is, for example, something like study program ID that the student is attending. And this, again, can be an integer. And can be, again, we can again send that it should be at least 1. And should we set it to nullable? I guess we can. This in some countries, it might be that you don't have chosen your major yet. So we have no study program assigned. And we also add another field, say email. Each student will have an email. Oops. And we can even tell that this field, although it's a string, we can even specify that it's an email. Okay, so we can select the format of this field to be an email. Okay, so this is a creation of a component or a model. Let's now move to creating an actual endpoint. I will remove these two that they created for us. Go here, path, and create a new path. And let's start with the /students endpoint that will give us all students in let's say our database. We can give the endpoint name, so say list of all students. And what we will do next is that we will add a response. this student, this endpoint requires no additional input from the user, just entering the URL. So we just go to responses, and here we can create different or define different responses for different status codes. In this case, we will just create the response for the 200 status code, and we will add a body to the response. In this case, we can say that instead of an object, we will have an array. Okay, so this endpoint should return an array of objects. Then down here, we can go to components and say that this will be an array of students. And this is how we can simply, very, very simply define a new endpoint. Now, let's also define the second endpoint that will give us information about one specific student. And we will again create a new path. We can start with students, and now we will use the curly braces to, let's make it like this, student ID, to say that there will be a URL parameter or an argument in the path. And we can even configure this argument here. So we say that the URL will be /students /some ID of the student. We can go to the path params configuration here, and we can say that this again has to be an integer. And if we want, there are other properties to define. We can again say, for example, it should be at least 1. So again, give it some name, give it one student. And again, we will just add a response. And if everything works well, we get 200. The response will be a single object. And we can say that this object will be a student. So we can again go to the components tab and select student. But now what can also happen is that we will enter an ID of a student that doesn't exist. That's not in our database. So we can add another response, and here we can select the status code that's bound to this new response. You can say that this will be 404, not found. And again, we can create a different body for this response. So in this case, let's say it will just return an object, and it will have, say, 2 attributes. And the first attribute will be status, and we can put a default value here, saying error, so give an error. And maybe we can add another field error that will basically tell us what error we get there. And again, we can say default here, say student not found. So we can define different responses for different status codes, different situations. Okay, let's now take a break from editing and commit our changes. So there is this big green button here, commit and publish. And this basically commits our changes to the Git repository. We can either use the branch that we already have, or create a new branch, based on this commit. So I will just use the branch that already exists. Click push. And now it's pushed to the repository. We can go back to our main page of the whole workspace, which can have different APIs. And we already see that we now got a mock server address. This can be accessed basically everywhere from the internet, but you can also use it directly from the interface. So let's get to our list of all students endpoint here. Here we can switch to mock server, and we can try to send an example API request. And here we get a sample answer from the server that should adhere to our API specification. If you got to get one student, here you can see that you can enter the student ID property here, just for fun, and again send an API request, and it gives you an example of an answer that again adheres to our specification. And in the mock settings, we can even choose to we can switch between different status codes. So now we switch to 404, we send the request now, it gives us a 404 answer. And as you can see here, there is a CRL, or however that's pronounced, command that you can directly enter into a command line and use from everywhere you want. But let's now get back to our API and at the last endpoint, the post endpoint, or the post operation on the student's endpoint. Since now we are sharing the same URL, we are still using the /students, but now instead of get, we are going to use the post operation. Here in the tabs here, we can switch to post and create a new post operation here. Again, we can give a name to the operation, a new student. Okay. And now what we are going to do is that we are going to add a body to this request, because of course it's a post operation. When we are doing a post operation, we need to send some additional data to create the new student. So we can do that by specifying the student in the request body. So we add a body, and now we can say that the body will be a student, and that's all basically that we need to specify here for the body. And again, we can add some response. So let's just add a very simple response that will be an object, and it will have one field. Let's call it status, and we say that the default value would be OK. And that's basically how we can create a post endpoint. Very, very quick and easy. And we can now commit, push in. Okay, and if we go back to the workspace, we see the new operation or the new endpoint here. Then we have an example of body here. And if we did everything correctly, if I remove the ID here because the ID is nullable, the request should work even without the ID here. So that's basically the main idea why I set the ID as nullable. So when we are creating a new student, we don't need the ID there necessarily. So and again, if we want, there is an example response or an example command here how we can call the endpoint in the command line. Okay, so this is how to basically define our API. And now maybe we can take a short break. And if you have any questions about Stoplight, about creating an API here, we can have a short discussion. Then we will move to very quickly to some basic implementations. So, yeah.
I was wondering if you edit any endpoint and then comment it stores the schema as an open API specification. Is that right?
Yeah.
So what happens, or how are conflicts resolved if multiple people are editing and commenting at the same time?
Actually, haven't tried this directly in Stoplight, but you can definitely resolve conflicts using like normal approach, let's say command line or some graphical Git tool, because it's essentially connected to Git. But I'm not sure how Stoplight itself, like the interface, handles conflicts. That's a good question. We haven't an opportunity to try this.
I'm wondering whether you can specify relationships between the different objects, like for example, one-to-many or many-to-many relationship.
I'm not sure that's a responsibility of the API. I think that's more on like your database level. Not sure if like in this context, if like defining how what an endpoint returns, if it makes sense to like specify one-to-many or many-to-many. But you can always like refer to various components. You can create like hierarchies of components. So, for example, if I go back to anything here, and let's say I'm here, student, I should be able to add a new attribute here, for some reason, student, and refer to another component. So that's possible.
Mm-hmm.
Yeah.
Is there a way to import the model from a database straight in?
Not directly from a database, but what you can do is I create a new model here. Let's call it test. Tests doesn't matter. There is this generate from JSON button. So what you can do is provide some example of how the output should look like, and it tries to kind of derive your model from that. So it's not directly like from a database, but if you have an example of what you want from the API, you can put it here, and it will try to generate the model from that. Okay, any other question? If not, I guess we can really slowly, just quickly explore the implementation, how we can quickly basically take this YAML file that's hidden behind this nice UI and implement an API from that. So what I'm going to do is I'm going to go to GitLab. I have to log in. Yeah, this is a perfect tag research. And here is our repository right here. As you can see, here we have a reference, and this is where our API lives, or the definition of the API. So I'm just gonna clone this repository locally. Yeah. And it's now in Stoplight demo. Yeah. Now I will just install the connection library that I mentioned earlier. We will do this in Python, and it's super easy. So we can go with install. That's right. Yeah. Okay. So now we have the connection library installed here. And what we can do is we will create just a very simple main.py file. And I will just copy and paste some code from my notes there. So we are not here the whole day. Yeah, and yeah, I will import the connection library. Okay, so this is very similar if you have worked with Flask before. The definition or starting a web server is very similar to Flask. But what we are basically doing is that we are creating a connection app, And here we specify the directory where we can find the API documents. Then there is this add API method that adds a specific API from a specific file. I think actually I need to change this to capital S. And then we can also say that we want to use something called Pythonic params. This basically means that it will translate, let me get back to the API definition. Yeah. It will translate the student ID camel case format into the Python snake case. So instead of capital I here, there will be an underscore and lowercase I here. So that's what the Pythonic params argument there does. And then we simply just run our web server. Now, hopefully, if we now run our main function, yeah, we get an error. But this error is basically caused by something that we didn't specify in the API yet. And that's that we need to set an operation ID for each endpoint. This guy here. This operation ID here needs to refer to a function that will be responsible for handling this specific endpoint. So let's say this endpoint here that will be responsible for getting all students will be handled by a function in our main module, and it will be called get students. This second endpoint that lets us get one specific student, it will be main.getStudent, so singular. And also the post here, we will say that it will be main.addStudent. Okay, so we need to add an operation ID. Okay, you can comment and publish. And let's get back to our command line and okay, and let's try to run main again. And we have this move forward to another error. This was expected. Now it tells us that there is no get students function in our module. And this is not a big deal. We can just create this new function and basically a function for each of our endpoints, and that will move us forward. So then we open our editor here, and I will again just copy paste here and add 3 new functions that at this moment do nothing at all. Okay, then save and run the server again. And this time it's at least running. That's good news. Now what we can do, I will open a new tab here. We can just verify that at least technically it works, even if it returns nothing at all. We can just try to do a request to our server that we are running. And at this point, it returns nothing because there is just a pass in the body of our get student function. So let's extend this a bit and modify this function here. We will just add a very simple static content here. And we will just return a dictionary. Yeah, this was my old example. So I will need to modify it a bit. We basically just want it's not working as I would expect it to work. We just want this part here. As you have seen, that I had some additional properties there before. but now it should hopefully work. I hope the indentation will be okay. I don't want to spend much time on etching it. So now if we call this again, we get what we got there. And as you could see, let's get back to file. All we are doing is basically returning a normal Python list with an object or a dictionary in it, and this is translated automatically by connection into a JSON response. So nothing, no special function to call here. We just return the contents in basically its Pythonic form, and it's automatically transferred into JSON. So that's how we can very simply define an endpoint as a function that simply returns something like a dictionary or a list. Let's now move to the get student here, and what I want to show here is how to return a 404 error, and also how to work with this command line or path parameters that we have in this endpoint. So as you might remember, when we defined this endpoint, we had this student ID parameter there, and right here. And this parameter is accessible to us basically just as a function parameter or function argument here. And as I mentioned, since we have that Pythonic params here, it translates the variable name into its Pythonic form, so it's student underscore ID. Here I just added a simple print, and in this case, just to show you how to return a 404 error, it's very simple. Again, we return a dictionary with our status and our error message, and then basically just type comma and the status code that we would like to return. So basically, we are returning a tuple of two things here. Again, if we run this, hopefully it works. Let's go back here. It was students, and let's say student number 20. And it gives us the error. I'm not sure, maybe if I put verbose here, it will also show the status code. Yeah, 404. So we got 404 command for 404 status code. And here, as you can see, we have the print command that prints the value of student ID, and we can find it. We can see it here in the console. So it's very easy to access command line parameters. And finally, let's have a look at the post endpoint here. Again, just a very simple, example that will do nothing at all, just print what we have received. To access a JSON body that was given us by a post request, what we do is we use this object request right here. So the connection library contains this global request object, and one of its properties is JSON, which basically gives us a JSON basically it returns a dictionary already processed into like a Pythonic data structure of what was received in the request body. And again, we can return some response. So let's go back to API. And now to make a post request in command line, it's a bit more complicated. So I have prepared that in advance, and hopefully it works. Okay, so here we are sending a post request on our URL. We say we also need to provide this header that we are sending a JSON data, and then the data itself as a string. Okay, let's enter. It gives us OK. This was the answer that we wanted to returned. And here in the console, since we had that print there, that prints connection.request.json, we see what we have received there. So we have received the data from the user this way. And then we can store it in the database or do whatever we need to do with it. OK, and finally, the last thing that I wanted to show you is how to, let's say, protect this endpoint by let's say, an API key. So go back to Stoplight. And what we are going to do is we want to protect this post endpoint that adds a new student with an API key. First of all, we need to go to this main API overview and add a new security scheme. In this case, we can just use an API key, but there are other options: HTTP, auth, to OpenID, connect. So depending on your applications, you can use these different options. And we can say that this will be present in the query of our request. So that's what you write in the URL after the question mark. And it will be found under this key. Okay, so we created a security schema, and now we just go back to our post request, and we add operation security, and we say that we want to use this API key security to protect this this endpoint here. And one thing that we need to do, and that's not yet available directly in the editor, we need to switch to code here and go to our security schema here that we defined. And that adds this little line here that basically tells a connection which function will be checking the API key that the user gives us. Okay, this unfortunately can't be done directly in the editor, so this one little thing has to be done manually directly in the file. Okay, let's commit and hope that everything works. Okay, so let's get back again. Full. Now, if we run Python again, yeah, great. It tells us that there is no check API key function in our main module, which is what we expected. So again, we added the here. Added the module here, and what we are going to do is just implement a super simple function here. Check API key. It again gets the API key provided by the user in the request as its parameter. We just print it, and what we are going to do here is that we are going to return a dictionary that contains this UID property. This is basically a signal that we verified or authenticated, authorized the user. So if we return a dictionary with a UID property, we are good to go. If we return something else, as we will see, we will get an error as saying basically that we are not authorized to access the endpoint. But for now, let's just leave it as it is. And again, start our server, and go back here and make a request that will contain the API key. So again, we are doing the same post request, but here now we added to the URL this query parameter here, API key equals hello, for example. Press enter. And now everything works as expected. We provided some API key. We didn't verify it in any way, but we can see here that it printed it as we expected. Okay, so it says hello as we would want. If we now use this alt command without the hello, or the API key parameter in the URL, you get a 401 error. So now it requires you to provide an API key, otherwise you can't access the endpoint. Yeah, and maybe the last thing that I will show you is if we switch this to, instead of returning this object, let's say if we just return none, so an empty value, and run everything again. Even with the API key, we would get an error. You can see the message is a bit different. In the first case where we had no API key in the URL, it says no authorization token provided. Now provided API key is not valid. So this is how we can very simply protect our API with, let's say, an API key. Okay, so that's it. So this was connection. It's a very simple library that lets you kind of connect the API specification that you write in Stoplight with your Python code. That's its main purpose. And basically, it runs in the background. It runs on Flask, but you can also switch to, I think it's called Tornado, which is basically a web server or in Python that uses how is it called, all that asynchronous features that new versions of Python provide. So it should be a bit faster and non-blocking and all that good stuff. Okay, so that's everything for me. And if you have any questions about Stoplight, about connection, you can now ask.
So what does the I assume there's a like pro paid version of the service,
Yes.
as well as like a free tier.
Yes.
What's the difference there?
Well, the main difference is in the limitation of in the number of projects that you can have in your workspace. So if you have the free variant, you can only have one project, one API per workspace. And I also think there is a limitation on the number of users in one workspace. So it's 3, I think. So I guess that's the main limitation of the free variant. Yeah, that I guess is one of the downsides of Stoplight. If you then need to pay for it, it actually gets quite expensive. Even I think the cheapest variant for like 5 users and 5 projects, if I remember correctly, it costs like $65 a month. So that's a big sum. But I think like even in the free version, it offers many useful features. And as I said, you can download a desktop editor. You need a user account on Stoplight, but you can then edit basically any file locally. You can open any folder that you have, let's say, cloned through Git locally and edit that directly. And you can do this as you want. So that's nice. Okay, so if there are no more questions, I will just say thank you for spending this morning with me. And if something comes to your mind later, you can just drop me a message on Slack. So thanks.